Hey, everybody, I hope you're doing well and welcome. We're finally here after over a month of live streams and everyone submitting and working hard on their plugins and their entries for the neural audio plugin competition. We are finally here and at the competition itself. So welcome. Thank you so much for helping out with this fantastic initiative. Thank you to collaborators, Christian Steinmetz and Andrew Fife, for helping to organize this. And a big thank you to the judges who have decided to share their time today with us and to give their feedback on the submissions. So we've had 18 submissions for the competition, which is fantastic. And we will show you, give you a walkthrough of all those things a little bit later. For now, maybe we could start off with the judges introducing themselves. So I'll call you out, and if you could just talk a little bit about what you do, and we'll start with Daniel Stein.
So I'm Dan. Thanks, Josh. Bit of a delay here. I'm Dan, also known as DJ Fresh, and I am a Brit-nominated producer with 2 UK #1 singles. I've DJ'd all over the world, but over the last 5 years, I've been working in tech, and I'm currently engineering manager at a company called General Bioinformatics in the UK.
Alejandro Koretzky.
Hi, everyone. I am Ale Koretzky. I'm the head of AI and audio science at Splice, where we've been building products and technology around discovery and creation. Our team is behind COSO by Splice that was launched a few months ago. Yeah, happy to be here.
Joshua Reiss.
Yeah, hi. I am the other Josh. I'm Professor of Audio Engineering at Queen Mary University of London. Last year, I was president of the Audio Engineering Society, and I'm also co-founder of a few companies in the audio space: Lander, Waveshaper AI, Nemesindo, and Roex.
David Trevelyan.
Hi, I'm David. I started my working career at JukeDeck, which was an AI music generation startup. I now work at TikTok, where I build real-time audio tooling for fun musical experiences. And our team recently released the Morph plugin. So that was us.
I think it'd be great to get an introduction from the co-hosts as well. Andrew.
Hello, everyone. It's good to see you all again. My name is Andrew. I'm an AI application engineer at Cosmo and the team lead on the Newton project, which I'm sure you've seen a lot of throughout this contest. So yeah, it's good to see you all.
Christian.
Oh, hi, everyone. Thanks again so much for being here. I'm a PhD student at Queen Mary University of London, working with Josh. He's my supervisor there. And my research is kind of in topics of neural audio effects and using machine learning and deep learning to control audio effects. That's why I'm here also. Yeah, I'm super excited for the final ceremony today and everything we have planned.
Great. And I'm Joshua Hodge. I am the founder and director of the Audio Programmer. We also have a great talk coming from Julian Lenz. Hi, Julian.
Hi, how are you doing? I've got a brief introduction slide, but my name is Julian Lenz, and I'm an intern at Cosmo with Andrew, working on AI for Symbolic audio. And I'm also a master's student at Pompeu Fabra University in Barcelona.
Fantastic. I think this is a great time to segue into our talk from you, Julian. Andrew, would you like to do an introduction for Julian?
Yeah, of course. Yeah, it's great to have another Cosmo member here today. I've got Julian, who's going to be doing his presentation on symbolic music generation. On another note, symbolic music generation. So yeah, Julian, take it away with your presentation.
Brilliant. And just to double check, can you guys see my slides okay?
Yep.
Wonderful. So yeah, I'm really excited to talk today about symbolic music. This is a big passion of mine. The goals of this presentation, I want this to be applicable to a wide range of people. So if you're not sure what I mean by symbolic generation, then hopefully this will be a nice introduction to the topic. If you're focused on audio generation, then perhaps this will show you how symbolic data could still be highly relevant for the type of work that you're doing. And if you're interested in developing symbolic plugins, then hopefully towards the end of this, we can talk about how Cosmo is working on some tools that could help you with that task. And I'll just say, I know that everyone is super excited for the results and the submissions, which are just an amazing level of quality. So I'll try to keep this brief and fun, and then we can get on to the announcements. Again, my name is Julian Lenz. I mentioned before, I'm working with Cosmo on symbolic music generation and in the final part of my master's at Pompeu Fabra University. Previously, I studied electronic production and design at the Berklee College of Music. I'm a classical cellist, and I did sound design with Output. So let's start with the basics. What exactly is symbolic music generation? Well, it's quite broad, but really it's any sort of system where at the end of it, the model takes some sort of input and it's going to output symbolic musical data. Now, these inputs can be a variety of things. It could be other symbolic data like MIDI or chord symbols. It could be audio, text, video, you name it. And the output also takes many formats, as long as it is symbolic, of course. So this could be MIDI, guitar tablature, music notation for software like Sibelius or MuseScore, chords, and so on. A very brief history, we didn't exactly invent this last year. It's built upon actually hundreds of years of development and research. So I think one of the earliest examples comes from a German composer, Kernberger, who in the 1700s developed a musical dice game where you roll a dice and the number of that corresponds to some notation. These were a set of rules that were manually created by Kernberger. A lot of people think that Mozart did this first, but actually Kernberger gets the first prize. But in a 50-year period, more than 20 of these games were created. So there was clearly a lot of interest in symbolic music, even back in the 18th and 19th century. Moving on to closer to the modern day, in 1957, the Iliac Suite was composed by two professors at the University of Illinois. This is widely considered to be the first computer-composed piece of music. It has 4 movements, and essentially the computer generates some random variables, which then, again, through sort of manual rule sets, are translated into some sort of music notation. If you haven't heard it, I highly recommend to listen. It's quite avant-garde, but it is a really enjoyable piece of music. From the 80s through till about 2010, I think the biggest focus was on things like Markov models, genetic algorithms, and other sort of rule-based methods. And these take on many variations and many forms, but the general idea is that there would be some level of rule making, which would correspond to, okay, how do we take a number and convert that into music? Markov models, for example, are still very powerful today. There's even some papers that suggest that they are still comparable or even better at composing music than certain deep learning methods. But perhaps the biggest drawback to these is that they require a lot of manual rule making by the developers, and they don't necessarily have long-term sequential knowledge, which is very important for composition. And of course, that brings us to the present day deep learning networks, which are all the rage. I'm sure I don't have to tell people on this channel. And of course, this has allowed us to take in a lot more data. The models can sort of teach themselves their own rules, and they have much better idea of sequential temporal measures. You might be asking, why do we work in Symbolic? I thought the dream of deep learning was just to get straight to the audio part. Let's skip everything in between. And so I'd like to briefly play a little, 2 little clips here. actually going to pop back in here. There we go. I wasn't getting the stop button. So you might recognize that. That's an excerpt of Bella Ciao. But if it sounds a little bit weird, that's because it is in a major-ish key. And that is actually a recording from what is probably the state-of-the-art audio generation model, which is Music LM by Google. And you'll notice that even though this is probably the most advanced model trained on a mind-blowing amount of data, it still gets confused about the differences between major and minor tonality. And so, you know, with something like spectrogram data, it's very dense data. Even for a couple seconds of audio, there's thousands and thousands of variables to be taken into consideration. So these high-level concepts like tempo, time signature, sections, chorus, these are things which the model probably won't learn unless it's explicitly trained on that kind of data. On the other hand, we have sheet music. And again, I encourage you to try to guess what this is from. And in a sense, sheet music can be considered a form of data compression because we're really isolating the music to its core components, the thing that are most relevant to human ears. And with that, I'd like to share a little quote, which I love, from Valerio Velardo from The Sound of AI, a frequent guest on this channel. He says, "Music is an orientated walk. The composer brings you on a ride with ebbs and flows of tension, determined by repetition, variation, and new material. This type of musical coherence is missing from deep learning-based generative models. The reason is that they have no external knowledge of music theory." There are some additional advantages of working in the symbolic domain, which I'll share here. The first one is integration. Of course, musicians are already quite accustomed to working with things like MIDI data or guitar tabs and music notation software. So when we create models that output this, it's quite straightforward for musicians to incorporate this into their existing workflows. Another one is speed. Because of that data compression that I spoke of, the size of these models is usually smaller and quite a bit faster. So if you're interested in making, for example, real-time applications, oftentimes that's much more feasible in the symbolic domain. Another one is copyright. In many cases, it's much easier from a copyright perspective to get training data than it is to get audio training data. For example, if you wanted to train a model on all of Beethoven's symphonies, it would be relatively straightforward to do that in the symbolic domain, but to train it on audio recordings of the symphonies would be a much more legally difficult task. And the last one, the most important, in my opinion, is the creativity. By definition, symbolic tools are meant to fit within an existing workflow of a music maker. And so these are tools that are really meant to enhance and increase the creativity of people and not to replace it. So some common tasks within the symbolic music domain. This is a wonderful book called A Comprehensive Survey on Deep Music Generation. I highly recommend giving it a read. And they create a 4-part taxonomy, which is score generation, performance generation, audio, and fusion. And for the sake of today's discussion, we'll be focusing on these top two, which is score and performance. And both of these are generally symbolic generation. The difference is that score generation is focused purely with writing the notes like a composer would, whereas in performance generation, you're also focused on things like velocity and micro timings, the things that make it sound like an actual human is performing it. So they have a lot in common, but there is a clear delineation between score and performance. The number of tasks that you can approach with symbolic is quite varied, but some of the most popular ones are composing new melodies, reharmonizing existing parts, creating variations on a theme, generating a full score from start to finish, humanizing a score, so taking something where the notes are already written it and now making it sound like someone's performing it, generating accompaniments. So if I give you a guitar part, can you give me a bass part and drums that match that guitar? Performance and compositional style transfer, as well as interpolating between multiple ideas, which I think is one of the most interesting ones. And there's a lot more, but I think you'll see that those are some of the most common tasks that these models are trying to solve. I will admit this was the most difficult part of preparing this presentation because there are so many cool models out there, but I wanted to share just a couple that really stand out to me. So one is Folk RNN. It's from 2015, which is kind of mind-blowing, almost 8 years ago. It's an LSTM network, which is trained on a variety of European folk songs in different key and time signatures. You can go to folkrnn.org and put in your settings. It'll give you melodies, which generally sound great. And you can download it, download the MIDI, and put it right into your DAW. Music VAE was released in 2018. This is probably one of the most well-known works by the Google Magenta team. It's a hierarchical VAE, which they used for a variety of tasks, such as generating new melodies, humanization, interpolating between multiple ideas. And they deployed these in a number of Max for Live patches, as well as interactive websites, which again, I really recommend checking out because it's a great way to see the power of deep learning models for creativity. In that same year, 2018, Music Transformer was released also by the Google Magenta team. This is the same transformer that's found in ChatGPT, although they modified mainly the self-attention mechanism to relative self-attention. And the idea is that this helps it maintain better contextual knowledge of things that have happened in the past. Because when you're composing, the previous motifs and melodies and ideas is a really important thing for the system to maintain in its memory. And I'm just going to share this video. I think this is one of the most brilliant visualizations. As it's composing the piano part, you'll see each line representing how much attention it's paying to the previous notes. I've seen that video 100 times and I still love it. Moving on, CVRNN, I think this one has kind of flown under the radar, but it's one of my favorites. This is a, a program that was written to help humanize piano performances. It uses a convolutional RNN network. And I think the results really speak for themselves. So I'm going to play that here. So this system was fed a fully quantized piano part, in this case a Chopin piece. Having a bit of trouble with playback, so I'm just going to reset that. There we go. So yeah, you can hear it adds things like micro timings and velocity to really, I think to my ears, it sounds like a human being is playing it. Controllability is a really big area of research in symbolic music generation, and Music Fader Nets is one of several papers that's really tried to tackle this. So they used VAEs with several discriminators within the latent space, and the goal of this is to make it so that you can have a single fader-like control of a high-level attribute, in this case, arousal. So you feed it a melody, and then you give it a value for arousal between 0 through 1, and it'll actually convert that melody to match that specified feature. In addition to introducing controllability, this really reduced the amount of training data that was necessary because they used a semi-supervised approach for the discriminators. In 2022, the Groove Transform was released from researchers at Pompeu Fabra University. So this is a transformer encoder network, and it's designed to take a tapped rhythm and turn it into a fully performed 9-voice drum kit performance. So it enables real-time control, and it's been deployed in a number of VSTs, including a short demonstration that I'll be giving shortly. So those models I hopefully showed just how diverse and brilliant this field is, but of course there are some limitations. One of them is that many models, not these ones, but others, are oftentimes benchmarked only on objective measurements. And if you're reading the research papers, it can oftentimes be really difficult to understand whether they actually sound good or not, because they haven't actually been benchmarked or shown to real human beings to determine the musical quality. I mentioned before controllability. Understanding how we can actually utilize the latent space of models and how we can direct their output is a very important concept and one that still requires a lot of research. a personal pet peeve of mine, but the majority of the data sets are quantized, so that limits how much performance generation we can do. There's a high number of data representation techniques, which means the field is quite spread out. This is something I'll talk about more in the next slide. And lastly, there's a lack of effective musician-friendly deployment. So there's this big gap between how many of these models actually exist and how many are actually usable for musicians in their day-to-day workflow. In terms of the data representation, on audio, this is less of a problem. So whether you're in the DAW, the plugin, or the neural network, you're going to have a vector of numbers. There's still a challenge, making it so the buffer size, the sample rate, and the delay is all aligned. And this is something that we tried to solve with Newtone. Whereas in Symbolic, you have hex data, you have abstractions, and you have numbers in the tensors. So within Python, there's a really nice library called MIDI-Talk, which attempts to have all these different translations. How do you get that abstraction into a float, a tensor? But no such thing exists for C++. And so we asked the question, would it be possible to build a symbolic plugin framework that can support most of these data representation techniques? So with that, let's take a little listen here. This is a plugin that we've been developing, which is kind of like the Newtone, but for symbolic data. And so what it's doing here is it's generating symbolic rhythms in real time. And it allows for controllability as specified to the model. And in this case, we're taking a tap rhythm and we're converting it into a drum performance. So you can hear I'm switching between different tap rhythms, different seeds, but I can load different pre-trained models into the plugin. And the inference is very fast. If I drag another rhythm into it, it'll switch almost immediately. I could probably jam with that for hours, but in the interest of the competition today, I'll keep it short. So for concluding remarks, there's an abundance of creative and powerful deep learning models. But getting these into functionally useful tools for music makers is still very much a challenge. At Cosmo, we are hoping to solve this with a similar approach taken for Newtone. And I'm losing my voice a bit here, so apologies for that. But thank you very much. And I look forward to seeing the presentation of the winners.
Thank you very much, Julian. We'll give a couple minutes for some people to come through with any questions that they may have. Are there any questions from any of the judges or from any of the co-hosts?
I wanted to raise a question, but first I want to say a great presentation and super nice demo as well. It's always a challenge to do a live demo, and it went really great. So awesome work on that. Yeah, but my question was back on something you said at the beginning of the presentation that I thought was really interesting. You know, I liked a lot the framing that you kind of were setting up in the intro, and, you know, kind of pointing out maybe potential limitations of raw audio-based deep learning models for music generation. And I also feel a similar sentiment, but I want to pose, you know, the opposite side question back to you and say, you know, given a large enough data set and a large enough model, isn't it possible that this model could learn music theory, for example? So I guess to frame that question directly, you know, do you think in your understanding that given access to all of the raw audio data in the world, that you actually could, with no knowledge of music theory, actually construct the music theory that we currently have today, given only that audio?
I think that's such a thoughtful question. So thank you, Christian. I think the answer is definitely. The question is how much training data you have and how much computing power you have. And particularly if you're going to run this model on a musician's laptop, will it be able to perform those computations? So I think the answer is definitely, but maybe at least in the short term, because there are very real limitations of how much training data you can get without copyright issues, and what musicians can actually run on their computers, there's maybe, those are some barriers. But absolutely, I don't see any reason why these, not only could they not discover existing music theory, but maybe even learn new music theory that we haven't, as humans, figured out yet.
Yeah, I wish I knew more on that topic to answer, to have an insight into the answer, because I think it might not be clear to me which one is true. Because, like, for example, just using language as an example, there are many examples in linguistics, right, where certain rules we can't actually prove why they're true if you only had access to the audio stimulus. So maybe for music there are similar patterns, but I don't know. I was just thinking. But yeah, thanks for your answer. I think the real time. Yeah, go ahead.
Sorry, just to tag off of that. I mean, if you watch one of Jacob Collier's shows on music theory, I mean, the way he thinks about theory is completely alien, even to people who have music degrees. Like, he's on another planet of genius. And so, you know, there's no one right way to analyze a chord or a structure.
Great. We had a comment in our chat, and if you have any remarks on it, be happy to share. Jeeves says, in the future, we could show an algorithm a scene and it will score based on the video. What if we train a model on movie scenes and scores?
I think that's such an exciting idea. Yeah. There is work at Cosmo, which is tangentially related to that. But yeah, the concept of making symbolic generation that's based upon a video input, I think you could do so much with that.
We have a question as well from Nick asking, how close is music theory to what music we actually make?
That's a beautiful question. I don't know if I don't know if anyone can answer that question. I mean, music theory is just one way of representing how we hear music. So it's not the end all be all. And you certainly don't need it to make good music. There's so many good musicians. Jimi Hendrix, who didn't know how to read music, had no formal knowledge of music theory. So I would certainly never say that music theory is perfectly aligned with how we hear music. But to take the other side of that coin, I would say it does a very good job of representing some of the most common things. I mean, a major chord is pleasant to, as far as I know, 100% of human beings, right? So we've encapsulated what is really a physiological thing in a computational, in a written down format.
Yeah, we have a great comment from Jonathan Weiner, who used to be the head of education at Isotope. Jonathan, who says, music theory may be an abstraction of something that has already occurred rather than being predicate for what happens next. I think that's a great way to describe it. Music theory, and maybe AI in general as well, in terms of it's really looking at past information to determine what to output, doesn't it? So yes, another great comment from Duncan McConnell, who says, it's great to produce models that know what we have done, but what are the opportunities for expanding on our concepts or breaking our concepts of theory? So maybe AI could help us do that.
Yeah, and I think that also ties in with what Christian was saying. I mean, in many cases, maybe the models could actually develop their own sense of musical theory. I think that's such an interesting thing to reflect on. But at the same time, you know, again, human beings have spent hundreds of years trying to create these systems. So I don't think we should throw it out right away at the same time.
Yeah, absolutely. We have a question from John Garrett, who asks, do you think there's a way to teach AI that mistakes can often be the most creative part of music? And teach AI mistakes?
You know, I think that's such a beautiful question. And I'll just answer that with another thought, which is that I often worry that the data sets, particularly in Symbolic, only contain correct takes, whatever that means. And they're oftentimes, like a recording session, they're oftentimes stripped of the errors. And so I think that's an area to explore, definitely. certainly many of the most amazing musicians consider errors to be a fundamental part of their process.
Yeah, it brings to mind something that I heard in a recent talk about describing how ChatGPT works from Wolfram, who, if everybody knows, is the creator of Wolfram Alpha. And he said that in LLMs that when they look at a word and they try to determine what the next word or what the next phrase is going to be, that is often, if you pick the top or most likely used phrase, that what happens is you end up with something very static. So they actually add a little bit of randomness that sometimes picks the phrases that are not the most commonly used ones and puts those in. And then that adds a little bit more of an organic type of feel to the entire composition. Maybe there's something like that for music.
Yeah, there definitely is. One of the knobs you saw was, I called it chaos, but it's actually temperature. It's that exact same sampling technique used in ChatGPT. Well, I won't say it's the exact same as ChatGPT, but it's the same concept, introducing some chaos. But yeah, and there's a broader point to be made there too, which is that people oftentimes rightfully talk about the danger of how the LLMs can make mistakes or even lie to us. But in a musical context, I wanted to make a mistake. I wanted to lie to me and play notes which are sort of out of domain. I think that's one of the most exciting things. If all it did was played 1, 4, 5 chords all day long, you know, that would be the most boring application of these tools, in my opinion.
Yeah, teaching machines to be human. Interesting.
Just a quick thought on that. I think it's hard for a system to break the rules if it's rule-based, you know. So the abstractions that these models that learn from data can give us, they can go pretty far in that sense, and breaking the rules in a semi-semantic way.
Fantastic. So it looks like we finished with the questions. Thank you very much, Julian, for that. Oh, I see there's one more question that's just come through from Duncan McConnell. I'm thinking of Harry Parch's microtonal instruments. Rule breaking adds something to the models, agreed. But what about deeper discoveries? So I think maybe that's just a open question or just an open thought. If anybody has any remarks, please feel free to chime in. Just give a second. If not, then I think we can move on. Thank you very much, Julian, for that really awesome presentation.
Yeah, thank you, everyone. And I'll say these questions were very thought-provoking. So thank you for the discussion. That was delightful.
Actually, there's one more question here that is relevant. Are you collecting data of how sticky the current AI plugins are as a way to reinforce behavior?
Personally, I'm not. I'm trying to think. I'm wondering if we could define sticky a little bit. Is this sort of how repetitive their outputs are?
Yeah. Ekom, if you're still in the discussion, please feel free to clarify, and we'll wait for a couple minutes. Or actually, what we could do is we can move on. Oh, he says, they say how long a musician plays with them. So how long the musician plays with the plugins themselves.
Like the interaction time. I'm not aware. I haven't read a paper that benchmarks that. But it's a very interesting thought, and I think could be a very valuable benchmarking tool. So yeah, another thing to reflect on, definitely.
Right. Okay, I think it's a good time for us to move on to the next part of our live stream. We have Christian and Andrew, who are the co-founders, co-hosts of this plugin competition and this initiative. And they're going to talk a little bit about the entrants that we've had for the competition. So I will now pass it on to Christian and Andrew.
Yeah, thanks so much, Josh. I'm gonna go ahead and share here. Yeah, so now we get to discuss all of the awesome work of the participants of the competition. We had, as Josh mentioned before, 18 submissions, all of them shown here on the screen, all doing really interesting stuff in the context of AI, machine learning, and audio plugins. So basically what we want to kind of give you just Andrew and I are going to give you a very brief overview and shout out to all of the different submissions. And we're going to give you access to their repos and their videos afterwards, so you can check in more detail and learn about the projects. Just to recap for people that didn't participate, all the entrants, what they did was build a plugin using the framework or platform of their choice and provide that to us in an open source GitHub repository, so that the rest of the community can build on and benefit from their work. And then they also provided us with a demonstration video of about 5 minutes in length that let them discuss about the design and concept of their plugin, and then also show their plugin in action working in a DAW and kind of show off all the cool features of what it can do. So before we get into the specific submissions, I also want to just kind of talk a little bit about some of the statistics of the entries. One interesting thing we looked at is, well, what frameworks were people using to build the different plugins? And Juice was a very clear winner here among the different entries. And there were 2 plugins built with iPlug2 and 2 plugins that used the Newtone framework. So Juice, I think, was a choice probably because of its flexibility and well-known establishment in the audio programmer community. But I think these newer other frameworks and newer frameworks like Newtone, were able to get some use in this competition. When it comes to the machine learning framework that was used for training the models or building the models that people were deploying, PyTorch was a clear winner here, and with most of the submissions using PyTorch. And there were, I think, 3 submissions that used TensorFlow. So at this point, it's pretty clear that PyTorch is maybe is winning on this side in terms of audio processing or audio generation models in the context of plugins. And finally, I think where maybe the results were the most interesting was for the inference in the plugin, what type of backend were they using? And here there's a lot of different options and a lot of different routes that have a lot of different trade-offs that we saw kind of a lot of diversity from the submissions. With Onyx runtime being the most common, but only by a little bit. And it was followed by libtorch, which is PyTorch's C++ backend. And then there were some people also using RT-Neural, which is a specific runtime designed for like real-time audio processing. Some people used Eigen, which is a C++ library for implementing matrix operations, and they were actually going all the way down to taking their neural network and writing the C++ code in Eigen directly to implement their layers. So there was a really big spectrum of how people chose to implement their plugins, which I think is really interesting to see, and I think will be interesting to reflect on for other people that are looking to build neural audio plugins after this competition. But yeah, now that's just a brief intro of kind of the overall statistics of the entries, but now Andrew and I are going to discuss about, just give a shout out to each of the entries and the participants that submitted them, so everyone can see their really cool work. And as I mentioned before, we'll share with you links to all of their repos after this so that you can check out the code in more detail. But first up is this project called Own Melody Generative Model by Tatsunori Hirai. And their project here was about using a LSTM network or variants of recurrent networks that you could actually train on your own melodic data, so that individual users could actually build their own generative model that they could then use to generate new melodies with inside their DAW, which is a really cool idea to kind of leverage your own data to train these models. We also had the Neural Resonator plugin from a team of 3 of Rodrigo Diaz, Louis Walsenholm, and Adam Benito. And Neural Resonator is another really cool plugin here that is actually using a neural network to predict the parameters of a model that is modeling a 2D membrane that lets you, for example, hit this membrane as a physical model and generate sound from it. So it's a really cool application that enables like a real-time interaction and sound synthesis. We also had the Dr. Mix AI synth, which was another really interesting submission from Martin Brosch and Theo Niesink. And they were using actually ChatGPT as part of their process to write the code for a DSP synthesizer, which they kind of have some commentary on in their submission. So I think while they weren't using a neural audio to process audio. They were using audio or AI in another context to build a plugin, which I think was definitely intriguing. Crashify, which was a plugin submitted by Cal Goheen and Matt Reiss, is a really interesting application of actually using diffusion models, which are a really popular technique in audio synthesis right now, with inside a plugin in a DAW. And so what they were doing here was using this a pre-trained model to actually sample and generate different types of drum sounds using this model that the users could then kind of tweak the sounds and put them in their DAW. We also had Hard from Yiming Wu, which was another really interesting application where, in this case, they actually proposed their own neural network architecture to try to disentangle the harmonic and rhythmic components of an audio signal so that they can then take two different sources and actually intermix the harmonic and rhythmic components, which was, again, a really interesting idea and really a nice demonstration of this kind of concept using machine learning processing. Then we had Cyclone from a team of 4 here. It was Faris Schultz, Christian Scheer, Amir Pasha Mobini Tarani, and Valentin Akfa. And they proposed a really cool looking plugin, has maybe one of the slickest plugins or UIs of any plugin I've seen, and was built upon this Rave model that's for doing neural timbre transfer. And they kind of put a lot of really interesting engineering and audio processing capabilities on top of this model that made it be able to do a lot of really cool things. Then we have Neural Note, which was from Damien Ronson, Tibor Voss, and Karim Morel. And they were building on the basic pitch model from Spotify, which is a transcription model. And so they were able to use that to, in the DAW, like live transcribe audio so that you could directly import that audio as MIDI into your session, which I think is a super useful and practical application of this tech. And then we had Sympact from An Yang, which was a plugin using, again, Rave to provide a tool in the context of sound design. So could you take some sound libraries you already have and then plug them into a Rave model, and then you adjust things in the latent space of that Rave model to actually change the timbre of the sound effects you already have to generate different variations. And so I think another really interesting application. We had the Neural Bender from Dmitry Galinsky, and this was another, maybe one of the most creative applications I've seen in this space of kind of using neural networks to filter audio, where the idea here was to actually take neural networks and, after you train them, change the interconnections between them so that they were doing very strange things that you could then modulate to create a lot of really interesting applications and sounds. And I'll pass it off to Andrew to take over the rest of the submissions here.
Cheers, Christian. So yeah, I'll take you for the next half of the submissions, as we have so many great submissions for this competition. So the next one here is a DDSP cross synth, which is actually a Newton model here, which is based off of the DDSP architecture, and as it sort of extends an extension on top of the DDSP architecture here, giving some more timbral control there. So it's very good for working with speech signals, and you can bring in a lot more of the timbral characteristics of the voice when working with this model, and it does sort of timbre transfer between one input sound to another sound. So next we have NN Comp by Michael Holmes, which this was a very slick looking GUI on this one, I have to say. A very responsive GUI with the very impressive visualization of the neural networks being used here, but essentially using a neural network to emulate different compression algorithms, being able to exchange the different layers and components of the architecture in real time. And yeah, just a fantastic looking and sounding plugin. Next we have Pianoforte, which this is one of the submissions using the Onyx runtime here for this. It's essentially doing sort of neural audio synthesis here, using a very particular algorithm on quasi-periodic signals. Some of the interesting parts is that it's very lightweight a model for generating sound, and the fidelity that you get out of this is quite incredible for the size of the model that's being used. And then we have Neural Circuit Deployment by George Gunturaz, who yeah, so unfortunately there wasn't a plugin that was submitted with this, but a lot of great research and work that he put in for this submission, and a lot of comparisons of different emulations, analog emulations of different guitar distortions, and yeah, you can see a lot of the detailed work there from this image. So yeah, it was a very interesting submission from George. And then we have another emulation of analog effects with Neurofuzz, which is a Newton model. So this was trained to emulate particular fuzz pedal with some additional DSP. I think a ring mod was also added onto this as well, and you can have control of the ring mod and the fuzz and the gain through Newton. So this sounded fantastic as a analog emulation of these pedals. And the demo video as well was also really cool to see someone jamming out on the guitar with Newton. So a great submission from Marco. And then we have GBD by XZY. I don't know how you pronounce that, unfortunately, but like, yeah, this was a really cool submission, doing some more similar to Julian with MIDI generation, symbolic generation, where you have some MIDI being played into this algorithm, and the plugin generates some output MIDI in response. So this was a great submission. And then we have the Grand Matron, which is a really cool looking plugin. It kind of reminds me of sort of either like a Eurorack or a stomp box effect here, but this is another analog emulation of the Moog filters, trying to control digital filters that emulate the analog modulation of the Moog units. So another great sounding analog emulation plugin by Nicholas Bilka. And then we have the Combobulator, which has a fantastic name by Rob Clouth, Andrew Sorkin, and Jacob Opuhichi, which is another timbre transfer plugin here with a lot of additional control, pre-processing and post-processing effects. We have some modulation in there as well with LFOs to control things, and a lot of really fantastic sounding, highly curated models there by some fantastic artists. So a really great sounding plugin using timbre transfer. And then we have Vroom.ai. So this is an interesting one with a lot of the text to image models that we're seeing around at the moment. This is a text to audio and does a really great job using audio LDM model as part of a plugin, allowing you to write some text that describes the sound and actually generate and synthesize using this model a sample that I guess follows what was described in the text and is played back as part of a sampler sort of mechanism. So another great use of text to audio here. And that's it. That's all our submissions. So yeah, thank you everyone for these fantastic, creative, innovative designs. Just so many different directions people went on, and it's just incredible to see how people are extending creativity using AI or bending AI in different ways to get creative effects. So yeah, just a fantastic outcome for this competition. Next, I want to pass it on to our judges that we introduced at the start. Just to start a discussion on these plugins as a whole, just talking about some of the submissions that we've seen. Some of the judges here have went through obviously all these plugins and went through the criteria and sort of judged what they enjoyed most from these submissions. But yeah, I think we'll take it away and start a discussion and see what the rest of the guys thought of the submissions. So we'll pass it on to kick it off. Maybe start with Ali from Splice. What was your take on these submissions? Did any pop out that you enjoyed the most? And yeah, what were your thoughts?
Sure. Yeah, I think, first of all, this was very exciting to go through all the submissions. I mean, teams did an amazing job. I think what was very exciting is that I think in the past we saw a lot of quick demos, like toy examples that are cool from a technology standpoint, but when it comes to real utility or potential for these things to become a user-facing product that creates value, we used to not see a lot of that. And I think in this case, I saw a lot of really creative thinking in terms of building things that actually solved problems, that things that could be very useful out there in the world, and deliver through a combination of, at times, really creative technology, but at times things that don't need to reinvent the wheel, built upon things that have been there for a while, but encapsulated in a completely new delivery package. And I think that was really, really cool to see. Some examples, I mean, top of my head, Heart, the idea of this crossfade for DJ, using a variational autoencoder with the twist of disentanglement of harmony and rhythm. But I love the simplicity of that. And there's a lot of utility and potential for those kind of products. So timbre transfer, a lot of good stuff. But that's kind of like the major takeaway. I'm personally really excited when I see cool technology, yes, but more excited when it can land on something that people can use on a daily basis. And that was a very pleasant surprise.
Yeah, no, you raise a great point actually about how things are being built on top of like past and previous and already existing DSP even as well. We've seen a number of the submissions there that are sort of packaging their models to work in harmony with traditional DSP, which is great to see the two coexist in these plugin formats, either with like pre-processing or post-processing DSP. So there's some great packages being put together that are sort of combining both. Yeah, I mean, David, was there any things that sort of caught your attention? Any things that you thought whilst judging these plugins?
Definitely. So I also had a lot of fun going through the submissions. It was really, really inspiring to see. One thing that really struck me was how people, in a few of the submissions, actually really addressed this problem sometimes that neural nets can be a little bit opaque in terms of what's actually happening, and that can sometimes make creative decision making with like actual purpose, like purposeful creative decision making, kind of difficult. Like if you can't make a change and then make a reasonable inference about what's going to happen out the other side, then it is, I don't know, it feels like it's a more difficult creative tool to use. But a couple of submissions actually really went as far as, exposing the internals of that network, whether that's through, kind of allowing the actual weights to be mangled in some way, or displaying the signal as it traverses through that network. I thought that was like really inspiring, and it helped. I think it's going to help users build a mental model of what's actually going on, and that's going to really aid creative decision making. So I think that was really, really awesome.
Yeah, no, it's a great point. That's a whole other thing that we're starting to see emerge now, is like, what is the UX and UI like when working with these neural networks, especially if systems are black boxes? How do you sort of represent that? How do you sort of communicate the control parameters to users? And seeing some of the submissions that have, for example, visualizations and perceptual controls that make sense with what they hear, it's great to see that there's been a lot more deeper in-depth work on trying to communicate this sort of stuff. And like NM-comp with the neural network connections, and then seeing the activations and things like that is like a great representation to give people some intuition on how these models are operating. So Josh, do you have any thoughts from when you were judging these plugins? Did you see anything that sparked your imagination? Any interesting comments that you can
Sure,
make?
quite a few. So first off, I was just incredibly impressed by the quality, both technically and creatively. I had high expectations and they were surpassed by quite a lot. Great ideas, great implementations throughout. There were quite a few things that stood out. Rave was incredibly popular as an influence as well as a backend. And, I expected quite a few, but it was dominant as an influence, the Rave architecture. And there were quite a few that related to emulation, analog emulation, classic circuit emulation. They're not by any means copying each other, but it's an illustration of how mature the field is and how successful the field can be in terms of doing emulation. A few stood out, not because they were great or not great, but among the 18, they stood out as being a bit different. So I think they were all mentioned to some extent when introducing all of them before. Let's see, Room AI was a sort of DALL-E for audio. Give me a sound that sounds like this under these weird conditions, and it worked brilliantly. The focus on almost all of them was on the sort of music side, the musical instrument, music composition side, musical production side. So I love seeing Sympact, which was applied more for sound design, game and film sound effects. And I think that is really an under-researched area compared to music and speech. Dr. Mix, of course, it was a sort of a meta entrant in that it wasn't a neural audio effect as such, but it was a neural system creating an audio effect. And I think that's absolutely valid. It's an alternative approach, but it at a minimum gets people thinking. And then there were submissions like the Neural Resonator, which had some really high quality back-end understanding of the physics of what's going on with instruments and surfaces and how they are modeled and things influencing the design. So it's bringing in additional level of knowledge, some sort of domain knowledge that then influences the neural architecture and makes the whole thing great. So those were a few of the standouts for me.
Fantastic. Yeah, no, again, it's a great point. Like so many creative ideas of linking, neural audio models with things that we already know, like physics-based systems or traditional DSP, and even talking about the sort of meta example with the Chat GPT building a plugin, that still makes me think of like, well, what sort of interesting interpretation does that model have on like DSP, for example? Like what sort of mistakes will it make that will give off like interesting timbre characteristics that, we would maybe, we would need to break to discover ourselves. So like, again, super, super interesting. And like you said, Rave, very common, very popular this competition. I think there seems to be an allure to these timbre transfer effects for the number of creative and sonic possibilities that you can get out of these algorithms. So it's great to see more and more models being built around these types of algorithms for sure. So yeah, Daniel, last but not least, do you have any comments and from the submissions that you judged earlier? Anything that you thought was that struck out as something interesting, super creative? Yeah, what was your thoughts on that?
Yeah, I mean, I thought there was some really cool and original ideas, and I would love to play with all of the creations that I've seen here. I'm sure that a lot of people that are watching probably would as well. So congratulations for coming up with such original and interesting ideas that people would actually use. I guess it's weird for me because I'm a big fan of technology and AI. Having been involved in tech and music startups, but also being an artist. And I think for me, seeing lots of the entries being focused on helping, on using AI to help people make great music as opposed to trying to remove humans from the process was really nice to see. And I think, you know, there's a lot of concern at the moment around some of the generative AI tools and how people feel like, you know, their jobs are at risk. And I think a lot of people are skeptical. So I think it's very important that as people working in technology and AI, that we're trying to use the technology to make tools that help human beings, you know. So I think it was really, really exciting to see some really great tools that people can use where we're using AI to help bring out the humanity as opposed to the other way around. I was looking, funnily enough, for a MIDI transcription tool just a couple of weeks ago, because an artist we were working with for my record label, we needed to record a live piano performance, and then we wanted to transcribe that to have a sort of MIDI reinforcement underneath with like a MIDI keyboard sound. So I was very blown away by neural notes. I was also blown away with hard. Obviously, as a DJ, I thought, well, we could talk about that later, but really, really cool stuff there. And just generally, yeah, lots of really great ideas and really exciting plugins. Yeah.
Amazing. Yeah, you raise a good point. Like when you reflect on all the plugins and all the submissions that we've seen, it's, you know, there's not been any examples that are trying to replace, you know, musicians. You know, I think all the tools that we've seen today are all extending creativity, extending what, you know, we can do as humans musically, and sort of pushing the boundaries of creativity. So there's not been from what I've seen, any threatening behavior. I mean, apart from maybe if you count that ChatGPT example, like coming after your DSP.
I mean, you guys are all real, right? None of you are AI agents, right? We're all humans in this room at the moment. As far as I can tell, there's no simulations going on.
How would you know then?
Yeah, as far as we know.
Well, I mean, you can see that I've got 10 fingers, so that's always a good start. You know, you can see the 5 fingers there.
Yeah, it's good reconstruction by the model, I think. But yeah, so yeah, fantastic just to get all your input and insights on all the submissions. I think at this point, you know, having reviewed all the plugins, discussed it all, I think it's about time we move on to revealing the winners of this competition, which is a crazy moment, you know. So yeah, I mean, Daniel, we will go back to the slides for this. Daniel, we'll have you
real quick, Andrew, before we
sorry,
start.
Christian.
You're good. You're good. Yeah, maybe let's just recap also what the prizes are.
Yeah.
Before we get into announcing. I can do that real quick.
Yeah.
But yeah, so we're offering 3 prizes today from all the amazing submissions, and the judges, you know, they gave you some of their feedback, but they also, you know, they had access to everything you submitted and looked in detail at all the submissions and checked out the video and the code to kind of do some scoring. And basically our kind of final prizes are a result of collating all of the scores from all of the judges together to kind of come up with what were clearly kind of the standout projects that the judges selected in this project, or from these projects. And yeah, we have a lot of great sponsors that have been sponsoring this event that are providing these prizes to all of these participants. And let's see, in the first place prize, we are offering a cash prize of $2,000, and this is courtesy of TikTok. And they also have Juice, Indio, or Max and Rainbow licenses also for free. And there, I don't know if this is still on the table, so we'll skip on that. But in the second place award will get a cash prize of $1,000, which is sponsored by the Audio Programmer and Cosmo, and more licenses as well. And in third place, which is sponsored by GPU Audio, a cash prize of $500. So thanks to these sponsors, we're able to, you know, give something back to the hard work that these participants put into their submissions, which as all the judges said, were a lot of them very high quality and clearly had a lot of effort behind them. Yeah, so with that, Andrew, I'll turn it back over to you to put off the announcements.
Yeah, thanks, Christian. Yeah, so with further ado, we'll move to Daniel to announce the third prize winner. Daniel, do you want to do the honors?
Yeah, so the third prize winner is Harmony Rhythm Disentanglement Audio Remixer plugin, which is also called Hard, which I think is much more catchy. And that was the kind of DJ remix tool that allows you to move to basically morph between different rhythms or harmonic content. And I was totally blown away with this because as a DJ, obviously we're used to kind of using EQ and filters and crossfaders to crossfade between different audio tracks, but to actually be able to morph between different rhythms, I thought was just completely mind-blowing. And as a DJ who plays a lot of different, I predominantly play drum and bass, but I sometimes play lots of different tempos in my sets. And it's always a problem trying to figure out how to go from like 180 BPM to 120 BPM. And you can do that with time stretching. But often if you're switching genres and you want to go between a house track and a dubstep track, that is quite hard to pull off. So, seeing the demo for this and seeing how it made two totally different styles of music be able to transition so seamlessly, I thought was just really amazing. And I'd love to see this technology in decks and like maybe Tractor native instruments or hardware units. So yeah, I thought this was amazing. So yeah, well done.
Yeah, well done, Yiming Wu, for that. That was incredible effort, and it sounds amazing as well. I should also say that a lot of the demos and resources around these submissions will release after this, so that you can check out all the videos that went along with that are publicly available around these submissions to check out how they sound. But another fantastic plugin, and well worth the prize winnings there. So we'll move now on to David to announce the second place prize.
Yeah, so back in the early days of my music creation journey, I used to love a plugin from Native Instruments called Absynth. And in Absynth was a tiny little kind of effects unit called Pipe. And I used to have so much fun with that, especially as a physics student, where I could kind of play around with this virtual microphone positioning on this virtual pipe. And the second place really kind of reminded me of that. The tool that they built is a creative tool that I've dreamed of existing for a little while, actually, being able to do that sort of thing. It really sounds like genuinely fantastic, and diving into the implementation, I thought their decoupling of the machine learning algorithm and the real-time algorithm, I just thought that was really elegant, and I can genuinely see it being really useful to loads of musicians. So yeah, congratulations to the Neural Resonator team. Second place. That was amazing work.
Yeah, fantastic. Well done, everyone, for Neural Resonator, Rodrigo Diaz, Luis Wolstenholm, and Adam Benito. Great sounding plugin, great concept. The amount of like different sorts of variation that you could create with this plugin was incredible, just by morphing all these different sort of nodes around and changing different parameters. You could get all sorts of sounds. So yeah, absolutely fantastic. So yeah, well earned the second place prize. So I guess there's a first place prize, and it needs to be announced. So we'll pass it on now to Josh to do the honors.
Thanks very much, Andrew. And so the winner is, drum roll please, virtual drum roll. This one goes to Cyclone. And yeah, Cyclone, it's a collaborative effort by an excellent team, Fabra Schultz, Christian Scheer, Ahmed Pasha Tarani, and Valentin Akva. Cyclone really is just high quality throughout, both in terms of the creativity in the concept, the technical aspects of the implementation, the challenging aspects, the creative and elegant user interface, really one of the nicest VST interfaces I've seen, the application and overall feel and quality of the results. So what's it all about? It utilizes neural timbre transfer technology to offer a new approach to audio production, building on Rave. It facilitates neural timbre transfer in single and couple inference mode. And so it enables a new artificial layering technique to be applied on incoming signals to create rich drum palettes with fuller atmospheres and simply transfer the timbre of a raw signal to another sound palette. So it's really all about timbre transfer and modification, and does it very nicely. You can find out a lot more in the well-written GitHub repository, get a real sense for it. And I just encourage people to download it and play around with it and watch the video and so on. And yeah, I'd like to say there were lots and lots of really good entrants. So the fact that this came first is yet another feather in the cap, because it was a very, very challenging competition. So thanks and congratulations.
Thanks very much, Josh. Yeah, congrats to the Cyclone team. What an incredible submission. But also, like Josh said, like congrats to everyone who also entered. We had 18 submissions, so very difficult to judge really, like who is number one, who's number three, who's number two. Like they're all fantastic and they're all super creative. So yeah, congrats everyone for all your hard work and for participating in the neural audio plugin competition. And yeah, we'll just finish here with just saying thank you for all our sponsors here: TikTok Juice, Cosmo. We've got MathWorks audio program, GPU audio cycling 74. So yeah, thank you everyone for helping make this happen. I'll pass it over now to Josh, who will see us out of this final live stream.
You're muted, Josh.
Yeah,
Which Josh?
Can never get through a live stream without doing that. Yes, thank you, Andrew and Christian, for that, and thank you to the judges for sharing your time. Took a little bit of time to score and look through all of those submissions, and we're deeply appreciative of the time that you've done for this. First thing I wanted to do was just give a big thanks to Christian and Andrew, who have been the co-hosts. So they, as I said before, about the third quarter of last year, so about September last year, we started discussing this idea, and it was a seed of an idea that it was a very large idea, and I wasn't sure how difficult and challenging it was going to be for us to get this off the ground. And it took all of that time for us to really get it organized, get judges in place, get sponsors to help pay for the prizes. And I especially want to thank them, because we have not been compensated at all for this competition. We've done this, and we've been meeting and doing and spending a lot of time on this, and especially Christian and Andrew have really dedicated a lot of their own personal time to really making this possible, putting together the scores, putting together the slides, reaching out, contacting judges. So really big shout out to Christian and Andrew, because this is just incredible what we put together. Also shout out once again to the judges. Thank you very much for your time, taking the time to score, taking the time to look at all the entrants. Thank you to everyone who participated in the competition. As many of the judges have already said, the quality of the submissions was very high. What is really more important to me than people winning or losing is the fact that I feel like we have done something that has really moved the bar forward, that has really done something for the community and really helped spark some innovation in the community. And I think that to me feels like the most exciting thing that's come out of this. So even if you were hoping to get a prize and you didn't, please, I hope that you please congratulate yourself, because you've really done something that has been a credit to everyone in the community. I loved Christian's original idea that all of these plugins be open source, because now they've sparked so much innovation, and now other developers have the opportunity to help build on top of this and help bring things even further. The last thing that I'll say before I sign off is this is not the end of this initiative. So we've already been in discussions about continuing this on the audio programmer on a more daily basis to ensure that we have continued initiatives to help spark even more innovation in this really exciting space. We'll have some more announcements about that very soon. And with that, thank you to everybody that tuned in to watch the competition. I hope that all of these talks. Oh, there is one thing that I've forgotten. Thank you to everybody who has participated in giving a talk or being part of a panel that has been part of the live streams the past month. Can't understate how much value that you've provided to the community, because now people will be able to go back, watch and learn. And there are people that may not be able to afford to go to university, afford to get a formal education. Now we have resources in place to allow people that don't have the resources for those types to get that formal education, to be able to go and to help get started. So that is just, that's the whole reason that we started the audio programmer in the first place. So, so please have a look back through the talks that have been happening the past 5 weeks. There are many talks given by leaders and pioneers within the industry that are phenomenal. So if you're looking to get started in this space, I think that there's enough information that's here on the channel to help you get started and help you get off the ground. And with that, I will sign off. Thank you very much to everybody who tuned in. Thank you to everybody, and we will have more news soon. There have been some people that have been asking about where they can access these submissions. We will have those online on the Neural Audio plugin page on the Audio Programmer website next week. So you will have access to the video, so you'll actually see what the plugins do. And you'll also have access to the GitHub page. So you'll be able to clone the repository, be able to fork off of it, and be able to hopefully build some more amazing things. So we hope to see you in the Audio Programmer community. And with that, we will sign off. Everybody have a great day and morning, evening, or afternoon, wherever you may be in the world. And we will see you soon.
Thanks, everyone.